For lesson 4, we are looking at adding and subtracting unlike fractions. So that's our only vocabulary term this time as well. So these are just fractions that do not have the same denominator. Last lesson we did same denominator or like fractions. So this time we're going to do unlike fractions or fractions with different denominators. So let's take a look at this example. The table shows the fractions of 1 hour for certain minutes. Number 1 asks us what fraction of 1 hour is equal to the sum of 15 minutes and 20 minutes. So when we break this down, we want to look at 15 minutes first. All right, so let's look over here at the chart. The number of minutes is this first column right here. All right, so if we look down here, 15 minutes is 15 out of 60. Well, that makes sense because we're looking at 15 minutes. All right, and that fraction of 1 hour is 15 minutes out of 60 minutes, which makes up 1 hour. All right, so then for 20 minutes, I look down here and I find 20. Well, that one's 20 minutes out of 60 minutes. Again, 20 out of 60. All right, so looking at this, all right, I have like fractions. They both have the same denominator of 60, so I can add those two together pretty easily. So 15 plus 20 gives me 35, and I'm adding the fraction, so my denominator stays the same. So, all right, adding those together, it's 35 out of 60. All right, so let's take a look down here. Number 2 says write each fraction of an hour in simplest form in the third column of the table. Well, let's go back up here. So in this column called Simplified Fraction, all right, which is right here, I want to take the fraction of 1 hour and I want to simplify that. So looking at this, so 5 minutes is 5 out of 60. Well, that's not the simplest form of this fraction. All right, I can reduce both of those numbers by the number 5. So if I divide 5 by 5, I get 1. If I divide 60 by 5, I get 12. So go ahead and see if you can fill in all those. Pause it real quick. All right, so why don't we take a look? So 10 out of 60, well, both of those can be divided by 10. So that becomes 1 over 6. 15 out of 60, we can divide both of those by 15. So that gives me 1 out of 4. 20 divided by 60, again, both of those can be divided by 20. So that gives me 1 over 3. And 30 divided by 60, well, 30 is half of 60, so that is 1/2. So there's all your simplified fractions. Okay, so number 3 says explain why 1/6 of an hour plus 1/3 of an hour is actually equal to half an hour. Well, that does seem kind of weird. All right, 6 and 3. All right, how does that get us to 2? Well, the reason is we have to think about equivalent forms of these fractions. 1/6 and 1/3 are not equivalent. They don't have the same denominator, so comparing them that way doesn't really work out. So look back up at this chart. So we're looking at 1/6 and 1/3. So 1/6 is right here, and 1/3 is right here. Well, look at the number of minutes that is. Well, 1/6 is equal to 10 minutes. So 1/6 equals 10 minutes. And then 1/3 is actually equal to, scroll up a little here, 20 minutes. Well, if I add 10 and 20 together, that actually gives me 30 minutes. Well, again, look at our chart. 30 minutes is right here, which is actually half of an hour. That's half of an hour. So it really does work out. That's kind of cool. So looking at alternate forms of those fractions, what do the fractions really represent? What quantity do they represent? That helps us understand how this 1/6 plus 1/3 is actually a half. So number 4 says explain why 1/12 of an hour and 1/2 of an hour is actually equal to 7/12 of an hour. Well, again, let's check out this chart. All right, check out this chart. 1/12 is actually equal to 5 minutes. So 1/12 of an hour is equal to 5 minutes. All right. And then 1/2 of an hour, well, we said that up here was 30 minutes. All right. So if we take 30 minutes and add it to 5 minutes, that's going to give us 35 minutes. All right. Well, let's think about that in terms of the hour. That would be 35 out of 60 minutes. And then we can reduce that, both of these, by 5, which actually gives us 7 over 12, or 7/12 of an hour. So it works out. So to add or subtract fractions with different denominators, first thing you're going to want to do is rename the fractions using their least common denominator. So you have to make sure those denominators match. I'll be honest, it doesn't always have to be the least, but that means you won't have to do as much reducing with your final answer. As long as they have that common denominator, you should be able to compare them accurately. Then you're going to add or subtract as with like fractions, just like we did in the last lesson. And if you have to, you're going to simplify your sum or difference. So whatever your final answer is, make sure that it's in its most simple form before you move on. So before you can add two unlike fractions or fractions with different denominators, rename one or both of the fractions so that they have a common denominator. So let's look at some examples. Number 1 here, we're going to take 1/2 and we're going to add it to 1/4. So there's really two ways you can do it. The first method would be to use a number line. All right. So with our number line, I've identified 0 and 1 because everything we deal with, 1/2, 1/4, are both less than 1. So they fall on the number line between 0 and 1. So when we plot on the number line, we always start at 0 and we start with 1/2. So I'm going to go out 1/2 and I'm right there. Then I'm going to add to it another 1/4. Well, I broke my number line up into 4ths. So I'm only going to travel another 1/4 of it, and that lands me right here at 3/4. So 1/2 plus 1/4 is equal to 3/4 according to this number line. All right. So that's a nice visual way to represent it, but it's not really the most common way you're going to do it. The most common way that you guys are going to deal with this is going to be right here, and that's with lesson 2. We're going to use the least common denominator. All right, least common denominator is always the easier way. So we're dealing with 1/2 and 2/4. So what we want to do is find a factor, a multiple that 2 and 4 share. Well, what do I mean by multiples? Well, when I say multiples, multiples would be basically counting by that number or multiplying it by its next term, if you will. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. So 2, 4, 6, 8. Those are the multiples of 2. Multiples of 4 would be 4 times 1, which is 4. 4 times 2, which is 8. 4 times 3, which is 12. So 4, 8, 12, 16. Those are the multiples of 4. And you want to find the smallest common one that they share. All right? So in this case, we have 1/2 and we have 1/4. Sometimes it jumps right out at you. Like I look at this and I can easily see the common multiple they share is the number 4. I can take this 1/2 and I can make that into a 4 by simply multiplying it by 2. Do that to the top and the bottom. So 1/2 is exactly the same thing as 2/4. They are the same exact value, just represented by different denominators. Now that these are like fractions, I can easily add them together. I simply add their numerators, 2 and 1, and that gives me that same answer I had above of 3/4. So we are dealing with rational numbers here, and we said rational numbers include integers. All right, so negative values is what we have to deal with. So let's look at one that has 3 terms, and one of them happens to be a negative. So we have negative 3/4 plus 5/9 plus 7/4. All right, so we're dealing with addition. If you guys remember, we've talked about these properties for addition and multiplication. One of them is called the commutative property. And the cool thing about the commutative property is it says we can flip-flop the order of an addition problem any way we want. And we can combine that with the associative property, which says our grouping symbols in an addition problem can move anywhere we want them to be. So that means we can kind of get rid of these parentheses here. We don't even really need those. And then we can move this order around to be whatever we want it to be. So I'm going to actually move this around a little bit to do this. So I have negative 3/4. I'm going to add 7/4 next. and then the 5/9 last. And you may ask yourself, well, why would you do that, Mr. Downing? And the reason that I would do that is because two of my fractions are already like fractions. All right, they're already fractions that I can deal with. So I'm going to focus then on this -3/4 and 7/4. All right, I want to combine them. I can add them now. They have the same denominator, so I just need to do -3 plus 7. Well, -3 plus 7 is 4, positive 4. I have 7 positives, 3 negatives. The 3 negatives cancel out 3 of the positives, leaving me with 4/4 plus 5/9. Now, 4/4, that's an odd-looking fraction. It's because it's not really a fraction anymore. It's actually a whole number. 4 out of 4 is the same as saying you have 1. So we now have 1 plus 5/9. And this is simply telling us that we have a mixed number. We have 1 and 5/9. That ends up being our answer. So see how we started out with 3 fractions. And by using a little bit of trickery, by moving some things around according to the commutative and associative properties of addition, we're able to find some shortcuts that get us to this mixed number of 1 and 5/9. For the next example, we're going to do some subtraction because we said this lesson was about adding and subtracting unlike fractions. So we've got -2/3 minus 1/2. So again, let's try it with the number line first. All right, so I have a nice number line set up since both of these, all right, are less than 1. I have it between 0, and then we went all the way down to 7/6. I kept it in 6, so you notice this 7/6 down here is on the other side of -1, which would have been 6/6. And you'll see why we kind of have to do that. So start at 0, all right, because that's where we are. Start, and we're going to -2/3. Now, since we're traveling by sixths, I have to think about what the equivalent of -2/3 and 6 is. Well, 3 times 2 is 6, so that means 2 times 2 must be 4, so I'm actually going down here to -4/6. This is the same as -2/3, all right? So that's how far I went down there. Then it says I'm taking away a half, so that would be 3 of the 6 to get to a half, so I'm going to travel another 3/6 until I get right down here to -7/6. So this actually comes out to be -7/6, which if we simplified that, we have 1 whole 6/6 in there. So this would be -1 and 1/6 is actually our final answer. So that's a nice visual, like I said before, but the reality is we're probably not going to use those number lines. What we are going to use, though, is our least common denominator. All right, so if we have -2/3 minus 1/2, I need to find a common multiple between 3 and 2. Well, 3 isn't a multiple of 2, and 2 is not a multiple of 3, so it's not going to be one or the other, so I'm going to have to change both of them. So what is a number that they are both multiples? Well, the first one that comes to mind for me is 6. All right, I can get both of these to be 6. If I multiply 3 times 2, that gives me 6. So do the same thing to the top. So that gives me -4/6. And then over here to get 2 to 6, I multiply it by 3. And I'll do the same to the top. So that gives me -3/6. So now I can roll with this. So I've got -4/6 minus 3/6. And you know what? I don't like subtracting. I like adding. So I'm going to change it to an addition problem. So I've got -4/6, and then I'm going to keep, change, and do the opposite of that second term. So I'm going to change that to an addition. I'm going to change this guy to -3/6. So I keep my 6 since I'm just adding. All right, and I've got -4 plus -3. Well, if I combine -4 and I combine it with -3, that gives me 7 negatives altogether. So I have -7/6. Well, how many sixths are there in that 7? There's 1 whole one, so this is really -1. And then I have that 1/6 left over. So that gives me my final answer of -1 and 1/6. Last example. We're going to add or subtract unlike fractions in a real-world problem. So we're going to use the table to find the fraction of the total population that has type A or type B. So how much of the population has one of these two blood types? Well, if I want to know how much of the population has one or the other, that means I need to combine them to see what fraction of the population that represents. So it's really type A plus type B. So type A is 21/50ths, and type B is 1/10. Well, can't combine them with these unlike denominators. So I need to find a common multiple of 50 and 10. Well, I know that 50 is a multiple of 10. And to get there, I would just multiply 10 by 5. So let me multiply my numerator by that as well. So that gives me 21/50ths plus 50 and 5. So 5/50ths. So then all I have to do is add my numerators. 21 plus 5 gives me 26, and 50 and 50, that remains the same. I don't actually add them. I just leave that as 50. So that gives me 26/50ths. But I'm not done. I can reduce that. Those are both even numbers. So looking at it, I know at the very least I can divide them both by 2 to reduce them. So 26 divided by 2 is 13, and 50 divided by 2 is 25. So what fraction of the population has blood type A or B? Well, 13/25ths of the population has type A or B blood. Guided practice, we have 8 problems in guided practice tonight. All right, remember, in some of those 3-term ones, you can move them around. Use your commutative and associative properties of addition to make those problems easier for yourself. Don't forget to do number 8. Answer that in a sentence for me. We'll talk about it tomorrow.